Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be going over Unit 3 Notes 1. So what we're going to do today is just kind of go over some definitions that you're going to need throughout Notes 3. So it's really important that you get all these definitions written down because I'm going to be using this vocabulary a lot. And it's important that you understand what each of these terms mean. So I do want you writing these definitions down. That way you have like a little mini dictionary in your binder. So let's take a look at the first definition, which is a term. What is a term? Well, a term is a number, variable, or the product of number and or variables. Okay, so terms can be separated by an addition or subtraction. So let's write some examples of a term. The number 3, that's the term. X squared, that's a term. So we have a number, a variable, or it could also be the product of numbers and variables. For example, 4x cubed, that's also a term. So each of those things represent a term. Next, let's take a look at base. So what is a base? A base is the number in a power that is being multiplied. So the number in a power that is being multiplied. The exponent is the power that tells you how many times to multiply that base. So here's an example. So if we have 2 to the third, our base is the 2 and the 3 is our exponent. We also could use letters. So if we had something like x to the third, x would be our base and 3 would be our exponent. So that represents base and exponent. Again, I'm going to talk faster than you can write, so feel free to pause the video to get these things written down. Alright, next, let's take a look at a coefficient. So a coefficient is the numeric factor of a term that has a variable. So that's really important that it has a variable. So if we have something like 3x, for example, a coefficient would be the 3. Okay, so if we have something like 3x, the coefficient is just the number outside. Notice that I didn't include the letter. It's just the number on the outside there. Next, the degree of the term is the exponent on the variable of a term. So let's say we had something like 4y squared. So the degree of this term comes from that exponent. So we would say that this term is second degree because the exponent is 2 on that one. Okay? All right, next, let's take a look at this next part. So next we have like terms. So what are like terms? So like terms are terms that have the same variables raised to the same powers. All constants are like terms. We'll talk about what that means in a second. So terms that have the same variables raised to the same power. So remember that the power is the same as exponent. So we could have something like 2x squared. Negative 3x squared, 4x squared. So all of these are like terms because they all have this raised to the 2 power. So that makes all of them like terms. Let's take a look. Now, what's a constant? A constant is a term that contains only a number. Constants have no variable parts. So that means that there is no letter in it. So 4 is a constant. Negative 2 is a constant. 1 million is a constant. Okay, so a constant is a thing that is just a number. And like we saw in the previous thing, all constants are like terms. Next, let's take a look at a polynomial. So now we've kind of been working up to this thing called polynomial, and that's what this unit is going to be on, is polynomials. And a polynomial is a set of terms separated by pluses and minuses. So all we're going to do is take a bunch of terms and separate them by pluses or minuses. So for this one, for example, I have 3 terms because they're separated out by pluses and minuses. We also could have thrown in a minus sign in there if we wanted to. So all of these represent polynomials, okay? Just as a side note, if there's no number in front of the letter, that makes your coefficient 1. Remember we talked about the coefficient in front of the term. If there's no number in front of it, that means that the coefficient is 1, not 0. It's 1. Let's take a look at the degree of the polynomial. So the degree of the polynomial is the largest exponent of all of the polynomials. So let's go ahead and let's take a look at that. Let's take a look at this polynomial. So I have 4x squared minus 3x plus 2. Now this x actually has an exponent of 1 on it that you can't see. So if there is no exponent on there, then the exponent is 1. So for this guy right here, the exponent is 1. But we want to look at our largest exponent, which is 2. So since it's 2, that makes this a second degree polynomial. Now down the road we're going to learn that that's called a quadratic, but that's what we're going to talk about more in Units 4 and Units 5. So the standard form of a polynomial. So a standard form is a polynomial when all like terms are combined and the terms are written in descending order. Okay, so the two most important things from this is that all like terms are combined and it's in decreasing order with the largest exponent first. So if we look at our polynomial up here, this is in standard form. We're going from 2 to 1 and a constant is considered degree 0. Well, let's write another polynomial in standard form. So all I want to make sure is that all of my like terms are combined. I don't have x squared written twice. It's all combined. And that my exponents are going in descending order. Your constant should always, always, always come at the end. Next, let's take a look at the leading coefficient. So the leading coefficient then is the coefficient of the first term when the polynomial is in standard form. So when we had this polynomial, 4x squared minus 3x plus 2. So 4x squared here, this 4 is my leading coefficient. I don't need to include the x squared. So if it asks what is the leading coefficient, all I would do is write 4. You don't, when you're asking for coefficients, you don't write out the letters. You just write out the number factor out in front. That's by definition. Okay? So let's take a look at an example of something like this. So biggest thing is when you're combining like terms, you can only combine things that have the same exponent. So for example, we have 5 cubes here. Okay, now I'm just going to do this for 1. So we have a positive 5 cubes here, and I have a negative 2 cubes here. Okay, then I'm going to use squares. So I have negative 2 squares here, and I have a positive square here. Now here's the biggest thing. I can only combine cubes with cubes. My squares are not going to cancel. So for example, this cube here can cancel out this cube here. This cube here can cancel out this cube here. This square here will cancel out this square here. Okay, so I'm not going to go through all of them, but the point of this was to show you that cubes can only go with cubes, squares can only go with squares, x's can only go with x's, constants can only go with constants. So you're going to use that principle when you're combining like terms. Okay, so let's take a look at an example. So given that polynomial, we want to put it in standard form. So I want my exponents to go in descending order. I notice that my largest exponent is x cubed, and now I notice that I have 3 of them. So what I'm going to do to combine them is I'm going to add their coefficients. 4 plus 3 is 7. So I'm going to keep their coefficients add the coefficients and keep the exponent the same. So it's going to stay x cubed. Then 8x squared minus 5x squared, I'm going to do 8 minus 5. That gives me 3. And then I'm going to keep x squared. Next, I have negative 3x plus 5x. 5x minus 3x is 2x. So I can go ahead and get rid of the x's. 8 minus 12 is negative 4. So again, just combining like terms. So now it asks how many terms are there? There's 1, 2, 3, 4. So there's 4 terms. What is the degree of the 4th term? Well, the 4th term is the constant. And the degree of a constant is always 0. So it's a 0 degree for that term. Next, it asks us to list all the coefficients. Now remember, when you're listing the coefficients, you're only listing out the numeric factors. So 7, 3, 2. Okay, so notice I'm not putting the x's with it. I'm just writing out the numbers right with it. Last but not least, what is the constant? The constant is the thing that's just a number. My constant here is negative 4. So I want you guys to go ahead and try this number 2 one on your own. So you're going to combine your like terms, figure out how many terms there are, figure out the degree of the 4th term, list all the coefficients, and find the constant. Okay? All right, let's take a look now at number 3. So for number 3, we're going to put this in simplified standard form. Okay, so to put it in standard form, I need to combine my like terms. So I'm going to take 3x cubed minus 2x cubed. Well, that's just going to give me x cubed. Okay, but I notice now that I have this 5x to the 5th. That's the largest exponent, so that needs to come first. So 5x to the 5th 3x cubed minus 2x cubed. My next highest exponent is negative 2x minus 4x. Now when I add negative 2 and negative 4, when you add negative numbers, they get more and negative. Again, I'm not changing my x. I'm just adding my coefficients, keeping those exponents the same. Then I have 4 plus 5 is 9. Okay, so that's your standard form. So now it asks us for the degree of the polynomial. Remember that the degree of the polynomial is the largest exponent. So that makes this a 5th degree polynomial. Then it asks us for the leading coefficient. Well, if it's in standard form, the leading coefficient is the first coefficient. But in general, the leading coefficient is the coefficient of the term with the highest degree, which is 5. Okay? Last but not least, write the following polynomial in simplified standard form. Okay, so I want you to write this in standard form. Make sure your exponents are going from greatest to smallest. Find the degree of the polynomial, which is the largest exponent, and the leading coefficient was the coefficient of the term with the highest degree. Once you're done, please make sure you get that Schoology quiz taken. Thanks for listening.